Hi all. That was a very nice and an affectionate introduction. Thank you very much, and I welcome you all for this presentation on special concretes. Because we have a lot of dreams and we have a lot of challenges in current days construction. How do we realize that with special concretes? There are lots and lots of newer varieties of concretes that we have now, unlike the earlier days when we hardly had a few varieties of concrete. Why newer concretes? First, this question may come to your mind. Why do we need new concretes at all? Are we not happy about what we already have? Now, generally, people have a fascination with the performance of steel. They feel that concrete also should perform like steel. That is one reason why we need new concretes. And there is a need for fracture toughness in our materials. Therefore, the need. Strain hardening, we always assume the linear portion of the stress strain behavior of concrete, whereas strain hardening is also desirable now. Therefore, that is another need. We always have lots and lots of structural challenges and architectural challenges in our structure. And of course, commercial needs is always a guiding thing. Today, it is not only construction, but even repair, rehabilitation, and retrofitting of structures also is an important component of our construction. And ecological concerns, today everyone wants to build green constructions or eco-friendly constructions, and therefore what varieties of concrete will cater to that. And more than all that, we talk about sustainable development, and dynamics of evolution ensures that everything that we have keeps on changing. Change is the only constant in life. There are several value-added concretes. That is what VAC means. Several value-added concretes. I will not get into each one of them. There are so many varieties of value-added concretes. Some of them which are important for today's situation in construction, I will take you through. Mainly, my presentation would focus on special concretes for structures related to housing and infrastructure projects. I mean, infrastructure projects include roads and bridges and so on. Housing can be individual housing or mass housing. Now, let us start with the precast construction that we have today in the mass housing sector. Now, a lot of precast precasting is happening in our construction these days, and particularly in mass housing, its usage is increasing day by day. I'll just take you through one of the very challenging precast construction that we had some time back. Now, BDA, the Bangalore Development Authority, 2 years back, they conceived with this idea of coming up with 3D precasting. Two-dimensional precasting, everybody knows. They thought of coming up with 3D precasting, three-dimensional precasting. They wanted to build more than 1,500 houses in 48 blocks, 32 units per block, and roughly the area of each house was around 400 or slightly less than 400 square feet. Now you see that the houses are constructed in a factory. It is not constructed in the site. It is a factory made product, just like your two-wheeler or three-wheeler. Now you can see you have a plant and an assembly line where the house is being built. Now this is a wall that is being constructed with single line reinforcement for the walls, normal reinforcement for the roof, and not only the basic construction, but also this kitchen slab and then electric points, tile fixing, everything is done in the plant itself, in the factory itself. Even, your washroom fittings, bathroom fittings, they're all fitted into this. And please note, this house is ready, but it is not ready in the site. It is ready in the factory. Now, how does it go to the site? When we are doing this construction in the factory, the substructure, that is the foundation, is constructed again using precast blocks which are transferred to the site, and the foundation is kept ready. Therefore, you have foundation getting ready at the site, house getting ready at the plant or the factory. Now, parts of the house are transported part by part. Roughly about 180 to 200 square feet of the house is transported, and it is taken to the site, lifted and placed. Now, what is important is this anchorage. Now, when the structure is brought and fitted into the foundation that is there below, how it is anchored, it is a challenge. Therefore, here also there were a lot of challenges, but then it was overcome with series of trials. And the requirement for concrete in this case is that it should get a high early strength so that we'll be able to handle it. Now, one above the other, like a matchbox, the entire structure is ready and the blocks are all placed one above the other. The house is ready. Now, even the staircases are fitted like that. If it is a dogleg staircase, two pieces are brought and they are assembled, and within 2 hours, the staircase is ready. Therefore, this is a story of precast construction in mass housing projects, and you can see how fast things can be if it is done in a factory. Now, another way of construction is a cast in situ construction. If you have in mind that precast construction is faster and cast in situ construction is very slow, this is one example of a mass housing project where cast in situ construction can still make it quite a fast project. Now, before we get into the case study, let us look at what is the specialty of the concrete that is used here. Now, we talk about what is called as a foam concrete. Foam concrete is not a very high strength concrete. It is a low density concrete, very easy to operate, very easy to pump. Its strength is hardly M15. That is good enough because we are replacing brick walls with this foam concrete. If it has 15 MPa strength, that is much more than sufficient. It is a lightweight concrete. Its density is not 2,400. It is hardly 1,000, 1,200. It can be brought down to 800 kg per meter cube also, 1/3 the weight of normal concrete. Now, what are the constituents of this? What is special about this? Now, it has got a base mix, which is very similar to the normal concrete, and it has got a foam. We add a foam into this. Therefore, it is called as a foam concrete. Now, what is the base mix? It is a OPC or a PPC that is added into this to make it a good homogeneous mix. And how do we produce? These are produced from adding sand and aggregates in the usual way, and the strength design is hardly for M15 concrete. And finally, as I said, you add a foaming agent, binding agent, water, aggregates, admixtures if required, etc. You can see how flowable it is, how pumpable it is. Therefore, it can be used for making the walls of the house very quick and very effectively. And making this foam also is a very simple thing. You have a foam generator which can be attached to the concrete mixer, and you can make foam. Now, where do you use this foam concrete? It can be for void filling, making of blocks, etc. And in situ walls, as you can see in the last photograph here. Now, let us come to the construction. Now, aluminum formwork and foam concrete makes an excellent combination. Now, aluminum formwork, though it is initially expensive because it can be reused nearly 200 times, it makes the total expenditure life cost analysis. If you take, it makes it much affordable. Now, with this aluminum formwork, the finishing is also very good. Plus, foam concrete makes it an ideal combination. Therefore, this is the story of a ground plus 4-storied structure in Ahmedabad. The entire superstructure was constructed at the rate of 4 days per floor. 4 days per floor into 4 floors. 4 into 4 is 16. Simple mathematics. In 16 days, the entire ground plus 3 superstructure was ready. Only electrical and sanitary fittings had to be done. How this was possible? Because it is aluminum formwork, the external face and the internal finish that you have, you don't need to plaster. It is a plaster-free structure. It is very smooth and it doesn't require plastering. Therefore, you save a lot of time. Therefore, you can see the entire form work being done by very few people, very ideal in the current situation where, having labor, trained labor, skilled labor is a very difficult thing nowadays. Therefore, very less number of people can handle this. I'll take you through one of the projects that we did that Ultratech was involved a few years back. That was in a village in near Gadag. Now, this is the place where we started this work, and this was day one. Day one was excavation. Day two was laying the lean concrete foundation. And third day, it was foundation up to the plinth. And fourth day, aluminum shuttering and one layer of single layer reinforcement for the walls and normal reinforcement for the roof. The whole thing was laid. It is very easy to do that, very fast also. Half a day, the work was over. The same day, evening, concrete was pumped. We brought concrete from Hubli and we pumped. You can see concrete is getting pumped. Concrete is poured into the walls and it is also poured into the roof. Therefore, the entire box of concrete, both the roof as well as the walls, can be cast together. Therefore, it acts like a shell structure and reinforced concrete shell structure. And because it is foam concrete, your concerns regarding the temperature inside, thermal conductivity, etc., are addressed. Foam concrete is much better as far as thermal conduction is concerned. Now, this is the fifth day when all the side props are all removed. Only the vertical props are remaining. Sixth day, the house is ready for opening. And seventh day morning, when the then Chief Minister came to the site to lay the foundation stone, he saw one building was already ready and he inaugurated that building. And for promoting this fast construction technology, we also got this CIDC Vishwakarma Award. That was in 2013. Now, the one more addition to this was done later on in the VBHC project Bangalore, where 1,800 apartments were constructed. And the challenge here is also to see that how much of strength we get for one day. Now, within one day, how much of strength we get. Therefore, the challenge was to maintain the required slump, because pumping of concrete was to the 19th floor, and also to ensure that smooth surface is there for the shear wall construction. About 80,000 cubic meters of concrete was produced with this kind of a condition or a challenge. So we used what is called as a wireless maturity meter system. What does this do? When concrete is poured into its place, the formwork, the aluminum formwork, we also drop certain sensors. And these sensors, when they are dropped into concrete, they measure the maturity of concrete. And this maturity of concrete can be gauged with the help of this wireless maturity meter system. It is a wireless system. You don't have to draw the wires, and it is captured at the office, and you can correlate it to the strength of concrete. That means these sensors inside concrete, they are able to tell you what is the strength of concrete inside that. Therefore, whatever we designed for 24 hours, we found that the concrete has already achieved the one-day strength in about 15 to 16 hours. Now, this wireless maturity meter, it was able to tell us that in 16 hours, the strength is obtained, and therefore you can remove the shuttering and go to the next floor. Therefore, this makes the entire system much more efficient than one-day strength. Therefore, that is the additional thing that we did in the case of VBHC project using the maturity meter. Now, let us move on to the high strength concretes. From low strength concrete, we will now go to the high strength concretes. High strength concretes are used in lot of projects, particularly infrastructure projects, road projects. We use a lot of high strength concrete structures. I'll take you through some of these examples. You take this Mumbai monorail project, which was done by L&T. Now, there were two varieties of concretes, M45 grade of concrete and M60 grade of concrete. Now, what were the challenges here? The challenge was to achieve 48 MPa for a M60 concrete in 28 days. 48 MPa I should achieve within 3 days. Why is it required? It is required for facilitating pre-stressed concrete construction. For stressing the concrete, it is required to have early day strength. Therefore, this is the mixed design that we adopted, quite a bit high in cement content, cementitious content. Please note, it is not cement content, cementitious material content, cement plus mineral admixtures, 565. Please note the water cement ratio is very, very low, 0.24. What was the required thing? We need to have a flow of 450 millimeters. A slump is measured not in verticals but in horizontal flow. In 3 hours, it should have 450 millimeters slump. Now, it is not just one pour of concrete that we should ensure. All the 65,000 cubic meter of concrete should have this property. And in this whole thing, M sand was used. I want to make this statement: M sand, a lot of engineers have apprehension even today. Therefore, there is no such a thing. Only condition is that M sand should satisfy the conditions which are prescribed as per IS 383. It is very good for structures, and you will get consistent strength in the structures. This is the pier concrete for which M45 grade concrete was used. And for the stitch concrete between the two beams and two guideway beams and the pier, you had M60 grade of concrete. That was a stitch concrete. It is a self-compacting concrete, M45 and M60 used for this project. This is a finished project, very good finish and excellent performance. Now, high strength concrete is all right. High rise pumping concretes. Now, we'll have to pump concrete to great heights. All of us know that Burj Khalifa is the best example that we have till now, where concrete has been pumped to a height of 550 meters. That means more than half a kilometer's height. It has been pumped in Burj Khalifa. But in India, right now, the record pumping is 250 meters. That is 1/4 of a kilometer. The example is of this one Avigna Park in Mumbai, where different grades of concrete from M10 to M60 concrete has been used. Flow of concrete was 500 millimeters, and with about less than 25% of fly ash, concrete was made. And as you can see, 595 kg per cubic meter. The challenge here is that flowability should be so high, more than 500 millimeters after 3 hours, so that we should be able to pump it beyond 100 meters with 100% M sand. This was possible to make it. And what was the quantity of concrete? 1 lakh cubic meters of concrete with the same kind of property. It is now possible to make with the mechanization that is available. Now, another example of high strength concrete is for roads. Concrete roads, there are a lot of concrete roads, and white topping that is becoming very popular in many places. White topping, those who are in Bangalore and Mumbai, you may say, no, it is taking a lot of time. But then let me assure you that the time that is taken is not for concrete, making it concrete road, but for all other reasons other than making the structure. Now, this is the quite a well-known nice road. Those who are familiar with Bangalore must be aware of this. The outer periphery road, that is nice road, which is made with M40 concrete. About 80,000 cubic meters of concrete was used for about 10 kilometers of that. M40 grade of concrete with fibers. In case of concrete roads, please note, fibers are desirable. I would say it is essential at the rate of 0.9 kg per meter cube, so that it helps us in the control of cracks. Otherwise, plastic shrinkage cracks, you will see a huge number of such cracks coming up on the structure. Now, these are the various photographs of the finished concrete pavement. This is near the toll gate. Very good construction. Even after 6-7 years, it has a life cycle of 25 years. Now, this is about cast in situ concrete. Now, concrete can be made just like in the housing, concrete can be precast also. Now, if you make it precast concrete, which is not very popular in our country, it is possible to make it precast, pre-stressed concrete pavement. The great advantage is that The pavement components are made in the factory, they are brought to the site and they are assembled. Now, this is a story of a road which was closed for traffic in the late evening, and within 12 hours, because these panels were already ready, but they were kept by the side, they were just assembled and the joints were completed, and morning, and it was grouted, all the joints were grouted, and painting was also done in the factory, and the road was open within 24 hours. This was in US. Now, this was a story somewhere else. In India, we were always feeling that precast concrete roads have not happened, but then the very first road has come up already in Nagpur. These were the photographs that are taken during construction. This small stretch of road, 400 meters of road in a very busy, narrow stretch. It has been done with precast concrete pavement. The concrete slabs were cast in the precasting yard, then brought to the place, and there were joints. You can see where the dowel bars are placed. They were all grouted, and the road is open to traffic. But yes, it was not in 12 hours, but because this was the first experiment that we were involved, and the precasting people and the people who were assembling it in the place, they took 2-3 days to do that. But then still you will agree with me that concrete road which can be made in 1 or 2 days time, it's an excellent thing. And I am very sure these kind of roads will come up, and the discussions are going on for one such stretch of road in Bangalore also, which will come up very shortly. Now again, get back to the concrete for repair segment, which should have a very high strength concrete, very high early strength. Now, how early it should be? It is in terms of hours, not even days, 1 day or 12 hours. I'll take you through the case study of the joint repair of the Belapur Bridge in Mumbai, Navi Mumbai, which is a very high, which faces a very high traffic. And the challenge here was to achieve 35 MPa in 24 hours. Therefore, we used what is called as a zip concrete or a rapid concrete, which was used in buckets. And the early strength was in 24 hours. We designed it for 40 MPa of strength in 24 hours. Now, another class of concrete is to get more than 100 MPa, 100 to 125 MPa concrete with high early strength. And it should have good fluidity and also segregation resistance. These can be used for several applications in infrastructure projects. Now, what are the properties of this concrete? In 24 hours, it gets 40 MPa of strength, and in 14 days, it crosses 100 MPa. Therefore, in 28 days, it can come to about 115 MPa strength also. And it has good strength, it has good workability, it has a good durability also. This has been tested in a third-party laboratory also, and that was an excellent success. Therefore, in India, making M100 concrete or M125 concrete is a reality. It is possible to do that. It has been done, and therefore it can be done. Now, one of my last examples that I would like to show you, if you are supplying concrete to a very inaccessible location, a very hilly area where the road is being constructed, you don't have a road to take concrete there. You have a running river. Therefore, concrete is made. This is the example of a floating batching plant across Brahmaputra Bridge in Jogigopa in Assam, where the entire batching plant was put on a and it was floated on the river. It was on a barge, fitted on a barge, floating on a river. It went to the site, and near the site, concrete was made, and it was pumped for the construction. This was the best example for supplying concrete to an inaccessible location. Therefore, friends, with this, I would like to conclude my presentation. You can see, though I have included very few cases because of time constraint, in conclusion, we can always say that the challenges that we today have to produce concrete or make very good structures within a short span of time. It is possible to make concrete because concrete is a very versatile material and it has always stood the test of time. And I would also like to end by saying that concrete is a democratic material. Why do I say this? Very much like democracy, concrete is something where anyone and everyone can participate, semi-skilled, unskilled, skilled. Everyone makes concrete in our country and it endures and it is also tolerant, just like democracy. Therefore, friends, with this, I would end my presentation and I thank you all for your patience. Thank you very much.